Now let's talk about the third part of labor supply, and this part is going to focus on female labor supply. So let's start with a table from the textbook. This is the international difference in female labor force participation rate among working age women. And it shows for a bunch of countries, a bunch of OECD countries from 1980 to 2010. And as you can see, almost all countries increased quite substantially. Like for example, New Zealand increased from about 45% to 74% in 2010. The only exception is probably Turkey, which actually even goes down from 1990 to 2010. Okay, and we can see the US or UK is increased from about 60% to 70%. And we already briefly talked about this, right? We talked about the increase in female labor's supply in terms of both the extensive margin and intensive margin. Here, the labor force participation rate is measured in terms of the extensive margin, whether to work or not. And we see a lot of increase in terms of labor force participation rate. If we also look at like in terms of intensive margin, we will also see quite substantial increase in terms of intensive margin. Women actually work more hours, and in general, women are more likely to work full time today than in the past. So if you remember, we also talk about like if you look at for the past 100 years, you will see even more dramatic increase in terms of female labor force participation rate, and also in general female labor force, female labor supply. So this is one of the most fundamental change in the labor market in the past century. The increase in female labor supply, right? Both the extensive margin and the intensive margin. The female labor force participation had increased a lot in almost all countries. And if we break down for a given cohort, for example, for people born in, say, 1950, female labor supply is increasing with age, up to roughly 50 years old. And for any given age, female labor supply is increasing with younger cohort, right? So, for example, if you look at people born in 1960 versus people born in 1970, if you look at their labor force participation rate and labor supply in their 30s, you will see that younger cohort, people born in 1970, work more than people born in 1960s. And we're going to talk about some empirical work on this as well. So, after talk about these stylized facts, so what are the potential driving factors? Can you think about that? If we wanted to talk about potential driving factors, we can talk about in terms of supply and demand. Right. So, first of all, we can think about factors come from shift in labor demand, increase in market wage, right? So intuitively, right, if this is supply, labor supply, and this is demand, if there's increase in labor demand, we will see an increase in market wage, and obviously that will increase females' labor supply. And so what are the potential reasons that there's a shift in labor demand? Well, you can think about maybe because women get more education, so their human capital is increased. Also, maybe there's less discrimination in the society, and etc. You can think about many different factors. Of course, the tricky part is how to prove that. And another driving factor is decrease in reservation wage. Right? That's basically the shift in labor supply. Right. For example, easy birth control, fewer children, or technological advance in household production. Right, so there are actually many papers on these topics. We're going to talk about one paper is on the birth control, and also a paper on children. But in general, right, like you can think about if there's a decrease in reservation wage, for example, easier birth control or easier to do the household work, then maybe there's a decrease in reservation wage and they are more likely to enter the labor market. So there's a shift in labor supply. If we look at internationally, if we plot international data, so in the y-axis here is growth rate of female participation. Here's growth rate of female participation, and the x-axis is percentage change in wage. And you can see there's a pretty linear, at least, and positive relationship between the increase in wage and the increase in female labor force participation rate, or in terms of their growth, right? You can see a pretty obviously positive relationship. And this is consistent with a positive sloping labor supply curve. And you can think about the pattern here is consistent with a positive sloping labor supply curve with shift in labor demand, right? So, right. So a shift in labor demand and So let me repeat again. This is consistent. So the international pattern here we see is consistent with a positive sloping labor supply curve and a shift in labor demand. So in country with higher labor demand, we will see a higher wage for women and also a higher female labor force participation rate. So here, let's see an example, and so let's take a look on a empirical example from the EITC. We talk about the EITC, right? So that's an income tax credit, right? So that's basically the government give wage subsidy to working mothers. So if you remember the theory we talked about, the theory suggests women will work more due to the EITC. Okay. Especially the theory predict unambiguously on the extensive margin. Right. So if you remember, the theory predicts unambiguously that at the extensive margin, the women will work more, but the theory cannot tell you by how much more. So we need empirical work, right? So we need to use econometrics to estimate the magnitude based on real-world data. Right? So the tricky part, of course, is how would you test that? Right? How do you estimate that? And we need a research design. To have a research design essentially means we need to find an appropriate control group. So in the US, the EITC is only eligible for women with children. So one empirical paper here, the treatment group is married women with children, and they use women without children as a control group. So this is a quasi-experimental design, right? Because this is a government policy. You cannot simply run a randomized control experiment. So what you can do is try to think about an appropriate control group and use difference in difference to estimate. So this is a quasi-experimental research design. Okay, and of course you can argue whether this is a valid control group or not. Okay, but here let's believe the control group is valid. So let's take a look. So let's see. So the first column shows the labor force participation rate before the legislation, and we can see that, okay, so first of all, a married women with children, their labor force participation rate is about 73%. It's lower than a married women without children. Obviously, I mean, women without children tend to have a higher labor force participation rate. However, we do see an increase by about 2.4 percentage point after the EITC legislation. And for the control group, we see nothing change. Okay. So this is a quasi-experimental research design. Okay, so we do hope that there's no change in the control group. Right? If you also see a change in the control group, I mean that's okay, but so in general, in a difference in difference or a quasi-experimental research design, we need something called the parallel trend assumption. The assumption is that the change in the treatment group without a treatment is the same as the change in the control group. Okay. So basically we say, well, if there's no treatment, the change in the treatment group and the control group should be the same. Unfortunately, we cannot directly verify that. But in this case here, because we don't see any change in the control group, right? It's 0. So there's a pretty good indication, a pretty good evidence for that the parallel trend assumption is true. And we can do a difference in difference, right? So that's 2.4 minus 0. So the difference in difference estimate is 2.4%. Right? So if the parallel trend assumption is true, then we know that, then we can say that the causal effect of EITC on labor force, on women's labor force participation rate is about 2.4 percentage points. Okay. So that's actually a pretty large effect. Well, it's actually not that large, right? It's about 3 to 4%, 4% change. But anyway, so this is an example. We use the real world data and research design. We've tried to find an appropriate control group and try to estimate the causal effect of a policy. And the finding here is consistent with what the theory predicts. Right, we do see a positive effect of EITC on labor force participation. Okay, so the next topic we are going to talk about is fertility and labor supply, right? And as you see here, right, we know that women with children tend to work less than women without children. I mean, that's a fact everywhere in the world. But the question is, do more children causally lead to less labor supply? So what are the sources of endogeneity you can think about? So can you think about some reason that having more children does not necessarily, the reason that women with more children work less is not because of children and because of other factors. I mean, that's a source of endogeneity, right? Or individual heterogeneity. Right. childbearing is an endogenous choice driven by individual heterogeneity, right? So, for example, you can imagine maybe women with a strong preference for children, they also have less preference for work. So in that case, it's because their preference, not because of children, they work less. It could be also reverse causality, right? So increases in labor market opportunity for women raise the opportunity cost of having children, right? So you see that women with better education, they have better market wage, they tend to have fewer children, right? And that's reverse causality, right? Because the opportunity cost of having children become much higher for these women. Right, but if we only compare women with children versus women without children, then that's going to be some causal effects from children plus all this endogeneity, right? I mean, we are pretty sure that there's some causal effects of children on labor supply, right? I mean, we know that having a child is, we pretty sure that having a child is likely to reduce labor supply, but we don't know how much, right? We don't know how much because we know, for example, the difference between 73% and then 95% here, some of them may be the causal effect of having children on labor supply, but it's also caused by like individual heterogeneity, people's difference, preference, and like some reverse causality, right? And obviously, we cannot simply run an experiment in which the number of children is randomly assigned to women. Okay, so that's the thought experiment we would like to have, right? So most labor economists will conduct this kind of thought experiment, right? So we know we cannot simply go out to run such kind of experiment, but we will think about what kind of experiment we would like to run in our mind, and then think about whether there's some real world events or policy or some source of variation similar to the thought experiment we had in our mind. Right. So in this context, if we want to estimate the causal effects on of children on females' labor supply, conceptually, we would like the number of children is randomly assigned. So can you think about some situation or some source of variation similar to the thought experiment here? Can you think about a quasi-experiment or natural experiment that exogenously affects the number of children? It's basically, in some cases, the people or women without the choice of the number of children. So one example is actually, it's a lot of people know, is use twins. Because if somehow you have twins, then you will have one additional child, and that's completely random. You cannot really control for that, right? So that's random. Here we're going to see another example. This is a very famous paper by Anguis and Evans. So this paper used a natural experimental research design, and their design is very clever. So their source of variation is the composition of children's sex, and we're going to see why that's going to affect children's the number of children. So we know the sex of children is random under natural condition, right? If people don't do abortion because of sex preference, then that should be random. And we know, at least in the US, that's the case, right? Gender selection, like abortion, is very, very uncommon in the US that we can essentially ignore that. And the author Angus and Evans, they notice that parents have a preference for mixed-sex children, and they can show that in the data. And as a parent, I can tell you, yes, we do have a preference for mixed-sex children. And so their design is that, so they utilize this source of variation, right? So we know, but I mean, we cannot choose. We cannot choose baby sex, right? So it's completely random. So they notice that because mother with 2 children of same sex are more likely to have a third child, or more, right? To have mixed sex babies or mixed sex children. Angus and Evans, they use sex composition as an exogenous variation in the number of children. In the paper, they actually also use twin births as another source of variation, but here we are going to focus on sex composition. So let's take a look in the data. So, I mean, because not everyone without mixed sex baby is going to have a third child or more, right? So we need a very large sample. So typically, the largest sample we have is census. So they also use census. They use the 5% US census because census is so big, especially in the US. So they use a 5% random sample from the census, and that's already pretty huge. That's close to 400,000 observations. Okay, so let's see. So these are the fraction of the sample, and we know it's roughly 50% girl, 50% boy, right? So we do see that in the data, about 50% of the first 2 children are mixed sex, right? So 1 boy, 1 girl, and 24% is 2 girls and 26% are 2 boys. So, so there's actually an interesting thing. So we actually know that the chance to have a boy versus a girl is not 50%. So naturally, there's actually slightly higher chance to have a boy baby. It's roughly about like 2% higher, right? So naturally, if you have 100 girls, naturally will be about 102 boys. And do you know why is that? The reason is there's actually an evolution story there. The reason that naturally there will be slightly more boys is because roughly after about 15 years, when they become teenagers, the sex ratio will be balanced again, will become about 100 and 100. And one reason is basically boys are more likely to die for all sorts of reasons. I mean, they are more reckless, they are more likely to die during the teenager time, and so there's a natural selection, or not really natural selection, just a natural sex balance mechanism. So there are slightly more boy when they were born, but after about 15 to 18 years, the sex ratio will be balanced again because some boys die. Anyway, that's just a side note. So but that's, you can also see that from data here. So we have about 26% boys, only 24% girl. It's not like 25% versus 25%. And it's not a sampling error because we have a really huge samples here. Okay, so let's see. So we have about 49% or 49.4% of mixed sex baby, and about 51% of same sex babies, same sex children. And if you we if we look at the whether the proportion of them had another child, so more than 2 children, for for mixed sex parents, 37% in the 1980 census has more children. But the proportion is much higher for the same-sex, for the parents with same-sex baby. So the difference is about 6 percentage points. Okay, so there are 6. So parents with same-sex children are 6% more likely to have another child, and the same pattern shows in the 1990 census. The results almost the same, and you can see that this is it. We will still have slightly more boys in the 1990 census. That's not because some sampling error. It's just naturally there's a bit more boys. Anyway, so let's see. So here, we argue that same-sex or like children's sex composition is random, but can we prove that? We cannot directly prove that's true, right? I mean, we don't really know what is truly random, but at least we can look at the parent or mother's characteristic to see whether mothers with same-sex children versus mothers with mixed-sex children, whether there's any difference in terms of their characteristic, in terms of their age at first birth, race, and the years of education. Right? And you can see that right, so all of the difference here are pretty small and insignificant, right? So nothing here is statistically significant. So suggests that people or mothers with same-sex children is the same as mother with mixed-sex children. And that is what we would expect if the sex composition of children is random. Right? So the finding here is consistent with our argument that the sex composition is indeed random. Right? So we don't see any difference here. Okay, so here is the then we look at the difference in the labor supply between mothers with same-sex children versus mother with mixed-sex children, right? And we would expect that mother with same-sex children to work less because they are more likely to have third child. And the good thing is, if we compare these two types of mothers, the difference here is going to be causal effect, right? Because they cannot decide whether they have a sex. They cannot decide the sex composition of their children. So if you compare mother with same-sex children versus mother with mixed-sex children, the difference here is going to be causal effect. There's no indigeneity. We don't need to worry about their preference for work, because we know that on average, even though we don't observe their preference for work, on average, mothers with same-sex children should have the same preference with like mother with mixed-sex children. It's just like here we show that their observed characteristic is the same. Their unobserved characteristic should be the same as well, like their preference for work, something like that. Okay, so let's look at their difference. So let's see. So first, so this is the so let's look at this is the we already see before, right? So the mother with same-sex children are 6 percentage point more likely to have 2 children. if we measure in terms of the number of children, on average, mother with same-sex children will have 0.0765 or roughly 0.08 more child. Right. I mean, most people, so not all people, so most people with same-sex children will not have a child, another child, right? Only some of them will. Actually, only about 43% will, right? So if we take average, that means on average, parents or mothers with same-sex children are going to have about 0.08 more child. Okay. But anyway, so then let's look at it here. So here is the labor force participation, the difference in labor force participation rate. And we can see that on average, mothers with same-sex children, their labor force participation rate is 0.8 percentage point lower than mothers with mixed-sex children. Okay, and if we take the ratio, right? So if we take the ratio, this guy 0.008 over 0.06, that will be the effects of having more than 2 child on labor force participation rate. Okay, and that's the number here. Okay, yeah. Right. Similarly, if we divide if we divide 0.008, the difference in labor force participation rate between our treatment group and control group, by the difference in the number of children, right? So we know that for each additional child, the mother will work. Sorry, the probability that a mother will less likely to work by about 10 percentage point. Right. Okay. And we can do the same for weeks work and hours work. And we see that, so on average, women with more than 2 child is going to work 6 weeks less per year, and they're going to work about 5 hours less per week. And if we divide it by the number of children, we get the effects of have 1 additional child. So having 1 additional child, on average, women will work 5 weeks less per year, and they will work 4 hours less per week. And the result has become slightly smaller in the 1990s. So this is something we call child penalty, and that's well documented that child penalty become smaller over time in the 1990s. And if you estimate the same thing in 2010, it's getting even smaller and maybe even not statistically significant anymore. But anyway, so the point here, just focus on the 1981 and see that here is the effects of the causal effect of having more than 2 children, or the causal effect of having 1 additional child on the labor force participation rate, and also on the intensive margin, how many weeks per year and how many hours per week. And there's also effects on like labor income and the family income. You can see some change here. Okay, so let me repeat again the findings. So on average, among women aged 21 to 35 with 2 or more children, mothers with same-sex child and mothers with mixed-sex children have similar observed characteristics. Right, so the treatment group, the same-sex children parents, mother with same-sex children, the control group, mother with mixed-sex children, they do have similar observed characteristic. And we argue that because the sex of children is as good as random, so the treatment group and control group should have the same unobserved characteristic, individual heterogeneity. They should be the same. And the comparison between treatment group and control group should be the causal effect. And we do find that we do find that mothers with same-sex children are 6 percentage point more likely to have more than 2 children and have 0.0765 more children than mothers with mixed-sex children. Okay. And on average, mothers with same-sex children are 0.8 percentage point less likely to work for pay, work 0.38 less weeks per year, and work 0.31 less hours per week than mothers with mixed-sex children. And if you take the ratio of this over that, you get the causal effect of having more than 2 children on the labor supply. Right, so this is the effect of having 2 more children on labor supply. Right? You take the ratio, or if you want to get the estimate in terms of the effects of 1 additional child, then you divide by 0.07. Okay, so these are all just look at the basically the simple difference between the treatment and control group, and take the look at the average difference, then take the ratio to recover the causal effect. More generally, if you read the paper, you will see that they also run the 2-stage least square regression, and they use same-sex children as an instrumental variable, or as an instrument. If you know some econometrics, you will know what is instrument. For us, if you don't know that, that's okay. Okay, you just need to know that, well, technically, you can use the same-sex children as an instrument. And regression, so why do we want to use regression? Well, again, regression can help us to get standard error, and we can do statistical inference easily. And also, if you are worried about other variable like gender, education, you can also control them in the regression. But again, if your research design is valid, if the children's sex is as good as random, whether control for this observed characteristic, it shouldn't matter. And in fact, we already show that the mother's characteristics are actually the same between the treatment group and control group. So even if you control them in the regression, it will not change the results. But anyway, so here's the regression result. So the first column is the OLS result, and we see that from the OLS result, women with more than 2 children, their labor force participation rate is about 18% lower. But we know that this is unlikely to be the causal effect, right? The OLS is essentially simply compare women with 2 children versus women with less than 2 children. But childbearing is an endogenous choice, right? I mean, women choose to have more children, so that is going to be endogenous. And we know this is 18% cannot be the true causal effect. And if we use the 2-stage least square, we use same-sex as an instrument, and we see that the causal effect is only about 12%. Okay, so you can see here about 6 percentage points are about 6 percentage point of the estimate here from the OLS is actually the bias. It's probably driven by individual heterogeneity. And only 12 percentage point is the true causal effect. And similarly, we can see that the true causal effect on weeks work per year is about 6 weeks, not 9 weeks from the OLS. In terms of hours work per week, it's not 7 hours per week. It's only about 4.6 hours. Right. So the OLS estimates are upward bias. Right. So they overstate the child penalty. They overstate the causal effects from they overstate the negative causal effect of having children on labor supply. Right? But still, we do find negative causal effect from having more than 2 children. Right? So it's still negative. And this is pretty intuitive, right? I mean, we know that having more children means the reservation wage is higher. Of course, women are going to work less. What we don't know is the exact magnitude, right? But here, use this instrumental variable, use sense-X as an exogenous variation, we are able to estimate the true causal effect with precise magnitude on the negative impacts of children on labor supply. Okay, let's stop here, and we're going to talk about belly next time.